A very warm welcome, students. Hope you have done wonderfully well in your JEE preparation, JEE mains, and let us look at this session for JEE Advanced and session on limits, continuity and differentiability. So what exactly you need to keep in mind while doing this chapter of limits, continuity and differentiability? Calculus 1 is conceptually very sound, so you have to be technically right in terms of getting the right answers, and also the algebraic part of it, that is lot of manipulations, calculations and simplifications will also be brought into this particular chapter. So it's a perfect blend of the entire JEE mathematics. So calculus, especially the differential calculus part, if you do, almost you would have revised the entire mathematics part of JEE. So let us look at this particular chapter of limits through some questions. First and the foremost question, the square bracket indicates greatest integer function. Greatest integer function. He is asking you to evaluate limit x tending to 0, integral part of x square by tan x into sin x. Limit x tending to 0, integral part of x square by tan x into sin x. Through this question, let us understand the paper setter's mind, how a particular question can be approached towards, and irrespective of the way, how to arrive at the final solution. So let us in detail look at what all possible solutions are there for this particular question. Now, start from where? You have to evaluate the limit x tending to 0, integral part of x square by sin x into tan x. So whenever you are evaluating integral part of any particular function, first you need to ask a question whether the quantity inside this integral part is an integer or is it tending to any integer. If it is not tending to an integer, then it is continuous function, so happily you can substitute and get it. So you have to check first and the foremost whether it is tending to any particular integer, and if it is tending to any particular integer, you have to observe whether it is tending from right hand side or from left hand side, that is whether the number is slightly greater than that integer or less than that integer. Now you have some known limits here. Limit x tending to 0, integral part of x square I can split into 2x, x and x, by tan x and sin x. So you have two very famous limits, x by tan x as x tends to 0, which is 1, x by sin x as x tends to 0, which is again 1. So on the whole, this quantity is tending to 1. This quantity is approaching, the quantity inside integral part is approaching towards an integer. Which integer? X square by tan x sin x is approaching towards 1. This part is clear. Now start the question. When it is approaching towards an integer, had it been half, absolutely simple question. But unfortunately this is approaching to 1. So the question doesn't end here. If it was approaching to 1 plus, that means this quantity, if it is slightly greater than 1, then this integral part would have been 1. Had it been 1 minus, that means if this quantity is slightly less than 1, then this integral part would be 0. So depending on whether it is 1 plus, 1 minus, either our options could be 0, 1 or does not exist. Now let me rule out some options, not for sake of doing this question, but how to analyze technically various situations. Now if you observe, this is an even function, x square is an even function, sin x is odd function, tan x is odd function, product of sin x and tan x is also an even function, product of even number of odd functions is an even function. So on the whole, this function is an even function. On the whole, this function is an even function. So what happens if it is an even function? There will be a beautiful symmetry about origin. Whatever happens to the right of origin, same thing happens to the left of origin. So यहाँ पे I need not evaluate RHL and LHL separately, waste of time. Whatever be your RHL, right hand limit, same thing will be your LHL. So, I need not evaluate both of them separately, they will not be different because this is an even function. There is a beautiful symmetry about your y-axis, whatever is happening to the right, same thing is happening to the left. So, limit extending to 0 plus, if at all you evaluate this, it is as good as evaluating the other side. So, our option of does not exist does not arise here. Answer either is between 0 or 1. So, this is the beauty of understanding. So, whenever you are doing a limits question, understand the function in its totality. That will reduce lot of steps for you. X square by tan x into sin x. Now, what is the question? This is approaching towards 1. You need to understand whether it is greater than 1 or less than 1. That means whether the numerator is larger or denominator is larger. So, if you see whether x square, if it is greater than sin x into tan x, I am not sure. If at all this is the case, that means numerator will be larger, this ratio will be more than 1, then happily answer would be 1. Had x square been less than sin x tan x, then you can say numerator is smaller than the denominator, this ratio is less than 1, integral part would be 0. So, now the question is whether identifying whether x square is greater than sin x tan x or less than sin x tan x. So, for that you have multiple ways of doing this question. Usually such type of inequalities we approach with monotonicity. Consider a function f of x is equal to x square minus sin x tan x. Our observation is for x greater than 0. What is this function? At 0, f of 0 is 0. If this function, if you identify it to be an increasing function, that means from 0 it increases. That means if for x greater than 0, f of x would be positive. That means x square will be more than sin x tan x. So, if I understand monotonicity, how to understand monotonicity? Find out f dash x. I will come to a simplest of all the solutions, but after analyzing in various different ways. F dash x, what will it be? 2x minus, what is the derivative of this? Sin x derivative is cos x into tan x minus sin x into derivative of tan x is secant square x. So, 1 secant x, I will keep it here, secant square x. If you see this, again I am not very sure whether this quantity is positive or not. To say whether the function is increasing or decreasing, you need to know f dash x whether it is positive or negative. Again you have 2x and another trigonometric combination. So, whenever you see x and a trigonometric combination, which inequality comes to your mind? For positive values of x, especially between 0 to pi by 2, x will be between sin x and tan x. This is true for all values of x between 0 and pi by 2. And because we are talking about 0 plus, we are exactly in this interval of 0 to pi by 2. Okay, this is what we know. But can we see that? Let us see 2x. Here I can see one tan x. यहाँ पे एक secant x sin से मिलाऊंगा तो then again I can see one tan x. So this is tan x into cos x plus secant x. Now can I see something here? I can see two inequalities. One, tan x is greater than x. Tan x is greater than x. And also cos x plus secant x, whenever I see, I should see it as sum of a number and its reciprocal. Especially because we are talking about extending to 0 plus, this is a positive number, even had it been 0 minus also it would have been a positive number. So, this is the sin cos x plus secant x is positive number and its reciprocal. Sum of a positive number and its reciprocal by AMGM will be greater than or equal to 2. And this quantity is tan x will always be greater than x. So, this is greater than x, this is greater than 2. So on the whole, what is this expression? 2x will be much smaller than tan x into cos x plus secant x, or this expression is negative. The function is decreasing function. F dash x is negative, so f of x is a decreasing function. Decreasing function, what happens? F of x, because x is greater than 0, we are talking about x tending to 0 plus, f of x will be smaller than f of 0 because x is greater than 0. Inequality reverses whenever you apply a decreasing function. So f of 0 is 0, f of x is negative. F of x is negative in the sense x square will be smaller than, that is, numerator is smaller than the denominator. Numerator is smaller than the denominator. So this integral part, it will be come out to 0. This integral part will come out to 0. This is one way of approaching to the question. Once you have identified that x square, you have to know whether it is greater than sin x tan x or less than sin x tan x. Is there any other way of doing this question? Yes, of course there would be. Let us see, x square, how is it related to tan x into sin x? Is this what we want? Yes. Now, I have product of two functions, and again, while looking at sin x and tan x, this is the favorite inequality which you all know. X will lie between sin x and tan x for all x belonging to 0 to pi by 2. Now, can we make use of this inequality here? Unfortunately, no. Why? Because one x is greater than tan x, greater than sin x, another x is less than tan x. So, one side you have greater than inequality, another side you have more than. So, you cannot multiply both the inequalities. You have x greater than sin x and then x greater than tan x. Though all the numbers involved in our discussion are positive, sorry, this is less than, you cannot multiply because there is a change in inequality. There is a change in inequality. So, instead what I can do is start with am greater than or equal to gm. Am greater than or equal to gm. How can I use that? Tan x into sin x, we know gm of these two numbers, both are positive because I am talking about 0 plus. See the advantage of identifying that it is even function. I need not have to discuss on both the sides, one side is sufficient. Tan x and sin x are positive numbers because we are talking about 0 plus. Gm will be less than or equal to their am. Fine. Now, from here also you can try to prove this inequality. You can square and then use this particular inequality. That is another way of doing the question. Let me come to even more simpler method than all of this. That is your power series expansion. What is the power series expansion of sin x? Sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial plus so on, yes or no? Now, as x tends to 0, especially 0 plus, now sin x is x minus some number, yes or no? And what kind of number is it? X tending to 0 plus, so this is a positive number. From x I am subtracting some small positive number. So, will this be less than x or more than x? From x I am removing some number. Though I am adding x power 5, x is tending to 0. X is an infinitesimally small number. So, x power 5, when you square 0.1, what happens? 0.01. When you cube it, 0.001. So, the small number, when you raise the power, it will be infinitely many times smaller. So, compared to x cube, you can happily ignore all other terms. So, what is sin x? It is x minus x cube by 3 factorial. That means sin x is smaller than x because you are subtracting. Look at the power series of tan x. What is it? It is x plus x cube by 3 plus so on. So to x, you are adding x cube by 3. So is this number more than x or less than x? And x will be more than x. Obviously, this discussion holds good only when x is positive, and that is what I am bothered at now. Okay, so these are the inequalities which you already know. Sin x is less than x and tan x is more than x. That is not our area of interest. What is our area of interest? X square by, now tan x, I cannot directly write it as x because my interest is not on x, but what is happening after x, whether it is smaller than that or more than that. So x plus x cube by 3 is what you can replace your tan x with using power series expansion, and sin x can be replaced by x minus x cube by 3 factorial, which is 6. So this is our limit approximately. Now you have to see whether denominator is larger or numerator is larger. So x square by x into x is x square. Then focus on the next highest degree term, which is x power 4 by 3 plus x power 4 by 3 minus x power 4 by 6. So is this a positive number or a negative number? This is a positive number. Because x power 4 term is there, you can ignore the higher powers of x. So this is a positive number. So which one is more, numerator or denominator? Denominator is x square plus some positive number. So denominator is more. This number is less than 1, hence this answer is 0. So for doing a one single question, you will have plenty of different ways of looking at that question. So where do we start? This is an even function. So whatever is the discussion to the left hand side of 0, same discussion will be there to the right hand side of 0. To understand whether the limit is 0 or 1, you need to see whether numerator is greater or denominator is greater. That is the simplest question altogether. Next question, limit extending to 0, x into sin of sin x minus sin square x divided by x power 6. What is the question? Limit extending to 0, x into sin of sin x minus sin square x divided by x power 6. Now here, is it necessary to discuss RHL and LHS separately? Tell me, is it needed to discuss RHL and LHL separately? No. Why not? This is again a even function, sin of sin x. Sin x is an odd function. Odd function, composition of odd function is also a odd function. So sin of sin x is an odd function. If you put a minus sign here, it will come out and then again it will come out. So it's an odd function. And x is again odd function. So you have product of two odd functions, which makes it a even function. Sin square x is a even function, x power 6 is a even function. Altogether it is a even function. So you need not discuss LHL, RHL separately. Any one if you do, automatically rest everything is the same. Now which method do you suggest me to use here? Shall I go with basic formulae? Very difficult because sin of sin x is not that easy to, and again there is a combination of algebraic and trigonometric. So it is not very comfortable to use your basic standard formulae. Shall I go for L'Hopital rule or El Hospital as many of you call? Shall I use L'Hopital rule here? That may make it very difficult as well. Why? You have to use UV rule here, and again sin of sin x into cos x, 2 sin x cos x, x power 5. So a lot of simplifications, one L'Hopital will not give you. You may have to differentiate multiple times. Power series expansion. Power series expansion, sin x, I can replace it by, what is the expansion of sin x? Sin x is x minus x cube by 3 factorial, which is 6. Shall I stop here? No, because we are doing it up to x power 6. Denominator has x power 6. So at least my focus should be on the next term as well, x power 5 by 120. This is what I can replace sin x with. Okay, here it is simple, but here it is sin of sin x. So inside sin, I have to replace again sine and again use the expansion one more time. So this will be a lot of simplification. Not that easy. Yes, you can do it, but not that easy. So can you tell me some trick where you can simplify this? So before jumping into L'Hopital rule or power series expansion, you should always think, the moral of the story is you should always think whether you can simplify the limit. Okay, here x power 6, I don't have a problem at all with this function. Only problem is with the numerator. Numerator is combination of algebra, trigonometry and also a composite set of functions. So if at all there is any mechanism with which I can simplify the numerator, that will be heaven. Yes or no? So how do I simplify it? By taking sin x as some t. Okay. So wherever you find discomfort in your indefinite integration, you substitute that is equal to t. Same discomfort I am finding here with sin x. So I will go for a substitution, sin x is equal to t. As x tends to 0, where will t tend to? T will also tend to 0. Sin x will also be 0 as x tends to 0. So how will this limit shape up to? Limit x tending to 0 is same as saying t tending to 0. X, what will it be? Sin inverse t. Sin of sin x what is it? T. So sin of t minus sin square x is what? T square divided by x is what? Sin inverse t. So sin inverse t whole power 6. Is this looking comfortable? Mostly yes, because this difficult most part is here. I will make it, I will divide by t and multiply by t. Now this is 1, limit t tending to 0, sin inverse t by t is 1. So this will have no contribution in the limit, simplest. So this is t power 6. Simply denominator is t power 6. So what I have done, I replaced sin x with t as x tends to 0, t also tends to 0. So this limit changes to t tending to 0 plus x is what? Sin inverse t. Sin of sin x is what? Sin of t minus sin x is t. So this is t square divided by sin inverse x whole power 6. In product, sin inverse x can always be written as x, or sin inverse t can always be written as t, or divide by t power 6 and multiply by t power 6. Sin inverse t by t limit will be 1. Happily you can replace it by 1. So this is that simple limit now. You know the expansion of sin t. What is it? Sin t is, we are looking up to t power 6. T power 6. So let me write t minus t cube by 6 plus t power 5 by 120. That's it, t power 7 and all, let me ignore. Sorry. Sin inverse t, what is the expansion? T plus t cube by 6, no change, plus t power 5 by 5 factorial. Additionally, you have 1 square into 3 square, that is 9 t power 5 by 5 factorial. So simply replace these two terms here and your question is solved. You can see t into t square getting cancelled, minus t power 4 by 6 plus t power 4 by 6 getting cancelled. You have to focus on t power 6 term. T power 6 term, how are you getting? Product of these two. 9 by 120 plus 1 by 120, which is 1 by 12, and then minus 1 by 36. So simply when you substitute, you just have the focus on t power 6, rest everything is getting cancelled. This limit will be limit t tending to 0 plus t minus t cube by 6 plus t power 5 by 120 multiplied by t minus t plus t cube by 6 plus 9 t power 5 by 120 minus t square divided by t power 6. So all the terms are automatically getting cancelled. Our focus should be on the t power 6 term. T power 6 term, how will you get? T power 5 multiplied by t, that is 1 by 120. This t power 5 multiplied by t, 9 by 120. So 9 by 120 plus 1 by 120 is 10 by 120, which is 1 by 12. Then product of these two, what is that? Minus t power 6 by 36. So minus of 1 by 36. This is 3 by 36 minus 1 by 36, that is 1 by 18. That is your answer. Okay, so just don't jump onto applying power series or putting El Hospital rule. Simplify, see if that some simplification is possible, and then everything will make certain sense. That is the moral of this question. Okay, ready for the next one? This is a pure power series question. Limit extending to 0, a sin x minus bx. Such type of questions are being asked regularly in power series. So you have to be having some hands-on practice on these questions so that you can do them comfortably. Limit extending to 0, a sin x minus bx. Just understand the logic here. X is tending to 0. You want the limit to be non-zero finite limit. You want the limit to be non-zero finite limit. Now, when will this be non-zero finite limit? As x tends to 0, if x square term is there, there is no need of x cube, because x cube will be many times smaller than x square. Many times smaller than x square. So, if x cube has to make some sense, then x square should not be there. If x square has to make some sense, x should not be there. So, what is the expansion of sin x? X minus x cube by 6 plus x power 5 by 120. Let me end it here. If need be, I will write the remaining minus bx plus cx square plus x cube divided by 2x square into, what is expansion of log of 1 plus x? It is x minus x square by 2 plus x cube by 3, so on. If need be, I will write the rest, otherwise not. Minus 2x cube plus x power 4. Where is x tending to 0? Now you can see 2x cube and 2x cube are getting cancelled. 2x cube and 2x cube are getting cancelled. What else are getting cancelled? Minus x power 4, this product is minus x power 4, and here you have x power 4. These two are also getting cancelled. So effectively, what are you left with in the denominator? 2 by 3 x power 5. 2 by 3 x power 5. So 3 goes up. So automatically, because you have x power 5 here, if your series stops with x here, answer will be infinitely large, but I want a finite number. So can there be a x term here? No. Can there be a x square term here? No. Can there be a x cube term here? If there is a x cube term, limit will be 1 by x square, which is again infinity. Can there be x power 4? No. So finally there should only be x power 5 term. Rest everything should vanish. Rest everything should vanish. Because if x is there, that will remain, rest everything can be ignored. I can only write x. And this limit will become infinitely large. So x term, x square term, x cube term, x power 4 term, up to x power 5, everything should vanish, and only x power 5 should be a non-zero term. So x term, what is it? A minus b, that should be 0. There should be no x term. X square, where can you see x square? Cx square. that should also vanish. So C should be 0. Then x cube should also vanish. Here you have 1 minus a by 6. This should again vanish. There is no x power 4. Already there is x power 4 missing. So next comes your x power 5 term. What is that x power 5 term? A by 120. So this will be a by 120 x power 5. A is automatically non-zero. A is how much? 6. A is 6. So just substitute a equal to 6. You can see the answer. You have the answer. It is 3 by 40. Very simple question, but you get such type of questions regularly. You need to practice them using power series expansions. Then another variety of questions which come to you in limits is the ones, they are the ones which look very complicated. They are the ones which look very complicated, but if you try to focus on some or the other element in the question, you will see there is lot of simplification possible. So the paper setter will just try to threaten you by making the question look difficult. The question is not difficult, it is only looking difficult. So at such situations we need to be patient and patiently look at e power log of whatever is what. Same thing, e power log x is x, e power log x is x itself. So this itself is an indicative that the paper setter wants you to be afraid of the question. He has in fact given you a very simple question. So e power log x is x. So first part is 2 power x minus 1 whole power x. And that is coming common. That is coming common from the numerator into 1 minus sin x, into 1 minus sin x. Whole power 1 by x. So whole power 1 by x, this x gets cancelled and here it is 1 by x. Divided by e power x log x is what? E power log x power x. So denominator is what? X power x. This simply x power x. Whole power 1 by x is x. Now you can see this is a very difficult looking question, whereas this is a elementary question of your NCERT. This is a standard limit. How much? Log 2. This is also a standard limit, 1 power infinity form. 1 power infinity form. Sin x is something which you can happily replace by x e power minus 1, or because this is e power infinity form, what you can do is write this as e power limit extending to 0 base f of x minus 1 is minus sin x into g of x 1 by x. This is a simple limit e power minus 1. So this is 1 by e log 2. Look at next question. Now suggest me, what is that we need to do in this question? What works here? Yes, who is telling me? Yes, perfect. Whatever you think, you do here. You want to go for L'Hopital rule, you go. You want to apply power series, you apply. But the mantra I told you, first clean the question, make it as simple as possible before you venture into doing whatever you want. See, sin x by x is 1, yes or no? By x into x, or sin x is equivalent to x. So there is no harm in product if you write this sin square x as x square. Okay, if this sin x, if you write it as x equivalent to infinitesimal, there is absolutely no harm in product. Don't do that when you have difference or any other combination. only in product you can happily do that. Then cos x. Cos x, what is the expansion? Cos x is approximately 1 minus x square by 2 factorial, which is 2, plus x power 4 by 4 factorial, which is 24, plus so on. This is the expansion of cos x. So you want me to use expansion? Happily I can. 1 minus x square by 2 power 1 by 3. If I need the next term, I will write it. Till then, let me temporarily ignore it. That will be needed only when all the x square terms are cancelled. X power 4 will be needed when all the x square terms are getting cancelled. Till then, there is no role for x power 4. If x power 4 terms are also getting cancelled, then focus on the x power 6 term. So, till x square terms are not getting cancelled, I don't need x power 4. Let me see if all of them are cancelling, then I will add that. This is what I can write. Now, what to do? You know your binomial approximation, 1 plus x whole power n is approximately 1 plus nx. 1 plus nx, or I am just using the binomial expansion. So, this is 1 plus x whole power n is 1 by 3 here. So, 1 minus x square by 3 into 2 is 6 minus 1 minus 1 plus nx is how much? X square by 4 by x square. So, you can see 1 and 1 are getting cancelled. X square will get cancelled throughout. What is your answer? 1 by 4 minus 1 by 6. That will be your answer, 1 by 12. Option D. So, what I have done is simply used binomial approximation with basic expansion of cos x. I can have already as well done it by power series L'Hopital rule. How to use L'Hopital rule here? Again, before applying L'Hopital rule, I will simplify the denominator, or let it be 2 sin x cos x is the derivative of the denominator. What is the derivative of this quantity? 1 by 3 cos x power minus 2 by 3 into minus sin x will come out. I will write it outside. Derivative of cos x is minus sin x minus, what is the derivative of root cos x? Sin x gets cancelled. As x tends to 0, cos x is how much? 1. So, this is 2 minus sin as it is. This is also 1. So, 1 power whatever is 1, 1 by 3 minus 1 by 2. That will be your answer. Okay. So, a very simple question. It is not just, you don't need to back up by whatever it looks like, just go on doing what you want to do. Don't ever get stuck. You will get a lot of easy questions in advanced too. Next question is a regularly asked question type. Limit extending to 0, integral part greatest integer function of x, greatest integer function of 3x, greatest integer function of 5x, so on up to greatest integer function of 2n minus 1x. ये देख के ही ऐसे लग रहा है कि काश greatest integer ना होता. Had this GAF function not been there, what would this question be? A very simple question, x plus 3x plus 5x plus so on up to 2n minus 1x divided by n square. Now you can see sum of first and odd numbers is n square. Sum of 1 plus 3 plus 5 so on up to 2n minus 1, sum of first and odd numbers is n square. N square gets cancelled. You have this answer as x. Had this integral part not been there, answer would have been x. Answer would have been x. But unfortunately, that is not the question. Unfortunately, that is not the question. Now let us see what is this integral part doing. How is integral part related to this? Integral part of x, we know it is x minus fractional part of x. Yes or no? So this whole thing I can write it as x minus fractional part of x, 3x minus fractional part of 3x, 5x minus fractional part of 5x, so on. So this sum, whole sum will come out to x minus, what are you left with? Fractional part of x plus fractional part of 3x plus fractional part of 5x, so on up to fractional part of 2n minus 1 into x divided by n square. This is the question. Okay, because this is not simply x but it is integral part of x, you also have this term, not answer is not simply x but also this term. Yes or no? Now see how to deal with this limit. Fractional part, whenever you see, you have to understand the most important thing about it. There are two important things about fractional part of x, rather three important things about fractional part of x. One, its range. Fractional part of any number, when you see, you should see it as a number between 0 and 1. Fractional part of every number, any number will always lie between 0 and 1. It can never be 1, it can always be 0 whenever x is an integer. And second thing is, it is a periodic function. It is a periodic function. It is periodic with period 1. And third important relation with fractional part of x is fractional part of x plus fractional part of minus x will be 1 for all non-integers and will be 0 for all integers. So this is another relation which will be very useful. So as far as fractional part is concerned, these are the three important things. Its range, it lies between 0 and 1. Its periodicity, it is periodic with period 1. And the relation which binds fractional part of x plus fractional part of minus x, this comes to you handy in your different integrals. Okay. Now, which we are not talking about periodicity here, we are talking about the range of values, because limit will always try to understand the function by its values. So, we are understanding this function by its values. Now, what can you say about this? This lies between 0 and 1. This lies between 0 and 1. This lies between 0 and 1. All of these numbers lie between 0 and 1. So, this numerator, it lies between 0 and n. The numerator lies between 0 and n. इसका least value कितना होगा 0, greatest value कितना होगा n. Now what is our question? By n square, by n square, and limit n tending to, sorry, this should be limit n tending to infinity. This limit should be limit n tending to infinity. Limit n tending to infinity. N is tending to an infinitely large number. N is tending to infinitely large number. When n is tending to infinitely large number, ये कितना होगा 0. ये कितना होगा, ये भी 0. So whether it is 0, then also it is 0. Even when it is maximum n, then also it is 0. So बीच में कुछ भी होगा तो it is 0. By sandwich theorem, you can say least value of this is 0. Greatest value of this limit is also 0. So whatever be the value of x in between, this will happily be 0. So finally, what is your answer? X. ये कहाँ से simplify किए हम? This we are talking about range of fractional part. Fractional part lies between 0 and 1. All these n numbers lie between 0 and 1. So numerator will lie between 0 and n. Numerator will lie between 0 and n. Our botheration is 0 by n square or n by n square. Now n square is a much larger number. N is tending to infinity. तो या 0 by n square होगा या n by n square होगा, irrespective of which case is, this ratio will definitely be 0. So for whatever lying in between, that ratio is also 0. So इसका वैल्यू कितना होगा 0. आराम से बता सकते हैं इसका वैल्यू 0. यहाँ पे सैंडविच थ्योरम वगैरह लगाने की जरूरत नहीं है, बस ये समझ लो कि ये 0 to 1 है, ये 0 to 1 है, ये 0 to 1 है. ये पूरा न्यूमरेटर जो है 0 और n के बीच में है. ये 0 भी होगा तब भी 0 by n square 0 होगा, n भी होगा तब भी 0 by n by n square 0 ही होगा. तो बीच में जो भी वैल्यू हो उसके लिए ये भी 0 है. सो फाइनली व्हाट इज योर आंसर? x. This limit will be x. अब यहीं पे x की जगह कुछ और फंक्शन दे देगा, some other function, some other function. So whatever the function be, this is should be your approach. Okay. This is a very simple question. Limit extending to 0. Denominator क्या हो रहा है? 1. Acha, so this should be limit extending to -1, limit extending to -1. This is becoming how much? 0, denominator is 0. So ये finite non-zero number होने के लिए numerator should also become 0. Numerator should also become 0. And x plus 1 should be a factor, not once, not twice, but 3 times. ये x plus 1 whole cube, x plus 1 whole cube, numerator में denominator में कट जाना चाहिए. Only then you get a finite number. And after cancelling this x minus 1 whole cube, you should be left with a non-zero constant term. Only then this will be non-zero finite number. So this term should have x plus 1 as a factor with a multiplicity 3. That is, x plus 1 whole cube should be a factor of this. So x cube का coefficient कितना है? 1. So this term should only be x plus 1 whole cube. No other option. That expression, that cubic polynomial has to be x plus 1 whole cube. Only then this will come out to be a non-zero finite number as your option. तो x plus 1 whole cube का expansion कितना है? x cube plus 3x square plus 3x plus 1. तो ये 3 है, b3 है, c1 है. बराबर सिंपल सा क्वेश्चन है, बहुत ही आसान क्वेश्चन. नेक्स्ट क्वेश्चन इज अगेन लुकिंग वेरी कॉम्प्लिकेटेड. दिखने में ही भयंकर है, करने में तो बहुत आसान होगा. जस्ट don't get scared by looking at the questions in advance. Most of them are very simple questions. Only thing is you have to look at them piecewise, partwise, and try to understand what they are. So you are evaluating in this question right hand limit of f of x. Look at the options what he is planning asking you to do. Left hand limit of f of x, left hand limit of f of x, right hand limit of f of x. So just you need to understand what happens to f of x. This is your function f of x. What happens to this f of x when x is slightly greater than 0 and when x is slightly less than 0. So let me look at f of x as x is slightly greater than 0. X is slightly greater than 0, that is x tending to 0 plus. 0 plus का मतलब है x is slightly greater than 0. हल्का सा. So which case are we talking about? X is greater than 0. Slightly हो या बहुत ज़्यादा हो, कुछ भी हो, x is greater than 0, so it falls into first case. In first case, x is how much? Slightly greater than 0. तो ये fractional part of x कितना, integral part of x कितना हो जाएगा? 0. जो भी नंबर है 0 से थोड़ा बड़ा 0.1 उसका इंटीग्रल पार्ट हो जाएगा 0. So this number is 0. So what is the limit which you are talking about? Limit extending to 0 plus tan square. Fractional part is what? X minus integral part of x. Integral part of x कितना है? X is greater than 0, slightly greater than 0, तो वो 0 है. Divided by x square minus integral part of x, ये कितना हो जाएगा? ये भी 0 है. So is simply tan square x by x. So this is limit extending to 0 plus tan square 1 by x. Now what is tan of an infinitely large number? Who can say? Nobody, right? Tan is a periodic function. If it is a multiple, you are tending to a multiple, odd multiple of pi by 2, the limit may be infinite or non-infinite. For other numbers it is finite. अब infinity multiple of pi by 2 है या नहीं है, nobody knows. So as x tends to infinity, what will happen to tan x? Nobody knows. So we cannot talk anything about limit extending to 0 plus. ये कुछ नहीं बोल सकते. This also we cannot say anything because this limit does not exist. It does not exist, not like it is infinite, just because as x tends to tan x का ग्राफ कैसे होगा? Now as x tends to infinity, whether I am positive or whether it is negative, that part also I cannot say. So you cannot say anything about tan of an infinitely large number. That is the reason this limit does not exist. You cannot say anything about the left hand side of the function. Now what else is left? x less than 0, x less than 0. What can we say in this particular case? X is less than 0, that means I am talking about limit extending to 0 minus. Function is of course this particular one because x is less than 0. Fractional part of x, fractional part of x, what is it? X minus integral part of x. Now whenever x is less than 0, that is extending to 0 minus थोड़ा सा हल्का सा negative number है, तो what is integral part of x? Minus 1. So this will be x minus minus 1 or x plus 1. Fractional part of x, what will it be? It will be x plus 1 whenever x is a slight negative number. So this is 1 plus x into cot of 1 plus x. X is tending to 0, तो ये कितना? 1. This is also 1. So this is root cot 1. Cot 1, is it positive or negative? Absolutely positive. 1 radian is about 53 something, which is acute angle. Cot is positive, so root is properly defined. So this is your option. From there, उसको square किया तो कितना आ जाएगा? Cot 1, and cot inverse of cot 1 is 1. This is also your option. Okay, so only thing is right hand limit does not exist here. Then this is another question where one standard result is very useful to you. Okay, this standard results comes to you regularly. Limit n tending to infinity 1 power k plus 2 power k plus 3 power k, so on up to n power k divided by n power k plus 1. Answer will be 1 by k plus 1. Answer will be 1 by k plus 1. This is a very important result. You can prove it with your algebra and also with your definite integral as a summation of 1 by n. You can take common integral x power k you will get, whose answer will be 1 by k plus 1. So this is a very standard result which you have to remember. Now this question is based on that. So here indirectly what I am saying is 1 power k, 2 power k, 3 power k, so on up to n power k, as n tends to infinity, this is equivalent to 1 power k plus 2 power k, so on up to n power k is equivalent to n power k plus 1 by k plus 1 is what I am saying. Indirectly this limit value, what is it indicating? As n tends to infinity, इसका value किसका equivalent होगा? Equal नहीं, equivalent n power k plus 1 by k plus 1 का equivalent होगा. So this is of the order n power k plus 1 is what you need to understand. Now look at this question. How I am using that here? R into R plus 2 into R plus 4 sigma R ranging from 1 to n divided by n power 4. Okay. So one way of doing it is, first evaluate this product, do the summation, कितने terms आएंगे? R cube, R square, R, no constant term, R तक आएगा. So evaluate all the sums, do lot of simplification and focus on the highest degree term, or otherwise before even doing the simplification, try to understand the nature of this question. What do you have here? R cube. Sigma R cube किसका बराबर होगा? n power 4 by 4. इसका डिग्री कितना होगा? इसका इक्विवेलेंट है n power 4 by 4. n power 4 by 4 का बराबर होगा. प्लस उसके बाद क्या बचेगा? 6r square. 6r square किसका बराबर होगा? r square, सिग्मा r square किसका बराबर होगा? n cube के बराबर होगा. And n power 4 के सामने n cube क्या होगा when n is infinitely large number? Because n is an infinitely large number and this is equivalent to n power 4, while n power 4 is there, will n cube make any sense in the question? Absolutely no. So simply ignore the term sigma r square. Similarly, sigma r will be equivalent to how much? R square, n square. As you can see, n power 4 here n square, will it even matter? Not. So this question is simply sigma r cube by n power 4, whose answer is 1 by 4. As simple as that. K is 4 for you. Okay. So don't just blindly simplify to get to a result which is redundant and which is purely dependent on the highest coefficient. So when you are bothered about the highest coefficient, just focus on the highest coefficient. Yes, perfect. This is not actually a question on limits. ये क्वेश्चन है समेशन ऑफ सीरीज का, telescopic cancellation, but just because there is a limit, I included this in limit. Much important reason is this is very favorite question for many paper setters. So very regularly you see questions on telescopic cancellation. So practice as much as possible this telescopic cancellation. R equal to 1 to n. Cot inverse is something which I am personally not very convenient with. I don't hate cot inverse, I like tan inverse more. So I'll write it as tan inverse. So tan inverse कितना हो जाएगा ये? Tan inverse 1 by r square plus 3 by 4. There is a reason why I like tan inverse, because मुझे tan a plus b and a minus b का ही फॉर्मूला याद रहता है, not of cot. तो cot के लिए फिर से derive करना पड़ेगा या कुछ और करना पड़ेगा. That is the reason I prefer doing things in tan. Up to you. If you know the formula, you can do it in cot as well. So telescopic का question है, that is clear. Telescopic cancellation तब आएगा when I have tan inverse A minus tan inverse B formula. Tan inverse A minus tan inverse B is what? Tan inverse A minus B by 1 plus AB. तो यहाँ पे 1 plus होना चाहिए. Whatever it is, 1 plus product of two numbers and their difference. यहाँ पे 1 plus तो नहीं है, 1 plus add करना पड़ेगा. R square is there, 3 by 4, 1 minus 1 by 4. So this is R minus 1 by 4. And this is 1 plus AB for me. So what are the factors? I can happily see R minus half and R plus half. So numerator I should see it as A minus B. Now it is tan inverse A minus B by 1 plus AB. Tan inverse A minus B by 1 plus AB, which is happily sigma tan inverse R plus half minus tan inverse R minus half. R ranging from 1 to n, n tending to infinity will come in the last. Now telescopic cancellation, all alternate terms will get cancelled. You will be left with first term and last term. First term is tan inverse half, last term will be tan inverse infinity, which is pi by 2, and there ends the question. Very simple question. Another question, limit extending to 0. See, in this question again, the reason for me to discuss this question is many questions look complicated, but they are not. Here you can see two variables in the question. Two variables are trying to make it very complicated, but there is a hint in that question that the limit is only on x, and finally there is no y to be seen. There is no y to be seen. So y का इस question में कोई role नहीं है. To start with, you can put y is equal to 0 and do the question, or you can put y is equal to 1 and do the question, whichever you are comfortable with. So answer is independent of y. So such small things, if you identify those things, life will become easy in the examination. Without which also let me try to do y square is getting cancelled. So numerator is what? एक्स स्क्वायर प्लस 2xy डिवाइडेड बाई, नहीं यहाँ पे x टेंडिंग टू 0 है तो x को तो कटना ही पड़ेगा, x को कैंसिल होना ही पड़ेगा, तो ये एक x बाहर लेके काट देता हूं, यहाँ पे भी एक x है, यहाँ पे भी एक x है, तो उससे कट गया। देन व्हाट आई एम लेफ्ट विथ 8y प्लस x plus root over 8y minus x, and x is tending to how much? 0. So this is how much? Root 8y plus root 8y. Root 8y is 2 root 8y. 2 root 2 times 4 root y is denominator. Numerator is x is tending to 0 root 2y. ये दोनों cancel हो गए, 1 by 4. That will be your answer. Okay. So 2 power k is 4. K is 2. So just that, don't look at the question and get worried. That is the only moral in the question. You can happily do many such questions. Similar to the one which we did, but इसमें थोड़ा summation उतना direct नहीं दिया गया. It's not given that directly. What is the numerator? एक सिग्मा ऑलरेडी है और एक सिग्मा है. So first this term is how much? 1 into sigma r is equal to 1 to n. Sigma r is equal to 1 to n r plus 2 into sigma r is equal to 1 to n minus 1 r plus so on up to, what will be the general term? Okay. General term will be sigma r is equal to 1 to, first term में 1 into है, second term में 2 into, so kth term will have k into, if it is 1 here, n minus 0, 2 here, n minus 1, 3 here, n minus 2, so n minus k plus 1 r, this is your general term. Then last में कितना बचा हुआ है? n into 1. Okay, so I can include a sigma here. I can do it as a double summation if need be. वो भी दिखा देता हूँ कैसे करना है, कैसे डायरेक्टली करना है वो भी दिखा देता हूँ. So general term का sigma, general term is what? K into sigma r is equal to 1 to n minus k plus 1. ये रिजल्ट तो डायरेक्टली लिख सकते हैं हम. क्या लिखना है? Sigma r is equal to 1 to n minus k plus 1 r, sum of first n minus k plus 1 numbers. How much will that be? Sum of first n numbers is n into, so sum of first n minus k plus 1 numbers is n minus k plus 1 into, इसको एक और जोड़ दो, plus 2 by 2. And k is varying from where to where? 1 से शुरू हुआ and n पे खत्म हो रहा है, divided by n power 4. This is the question. Okay. So if you recall this and club it with the question which we did, now here 1, will it matter? 1 into k into any constant. These constant terms will not give you numbers which are equivalent to n power 4. They will not give you numbers which are equivalent to n power 4. If you recall the question which we did, r into r plus 2 into r plus 4, these 2 and 4 were irrelevant in that question because they were not giving terms of the order of n power 4. So here also this plus 1 and plus 2 are irrelevant in that question. That is where you can do your first simplification. Limit n tending to infinity, sigma k is equal to 1 to n k into, what do you have then? N minus k, n minus k. N minus k whole square is n square minus 2nk plus k square divided by 2. I will bring it here, 2n power 4. Okay? This is much simpler than this particular question. Now, first part of the limit, n square gets cancelled. सिग्मा के बाई एन स्क्वायर कितना हो जाएगा 1/2, ऑलरेडी एक 2 है 1/4. नेक्स्ट स्प्लिट इनटू 3 सेपरेट लिमिट्स, एन कट जाएगा, 2 कट जाएगा, सिग्मा के स्क्वायर बाई एन क्यूब, के स्क्वायर बाई एन क्यूब, हाउ मच विल इट बी 1/3. नेक्स्ट वाले में सिग्मा के क्यूब, सिग्मा के क्यूब बाई एन पावर 4 कितना हो जाएगा 1/4, एक और 2 है 1/8. That will be your answer. Okay, so we avoided lot of simplifications here. That is the whole moral of the story. So if you focus on what is important to you and what is not in the question, you will be able to avoid lot of calculations in the question. Is that clear? We'll discuss 2 more questions and see how these simplifications will be useful to you. The most preferred method here in this question would be to rationalize. Okay, so I will also not disappoint you, I will also rationalize. We can as well do a lot of other things, but I will also rationalize this for you. So rationalization will give you what? Root a minus root b, you have to multiply and divide by root a plus root b. Okay, so I will have this bulky expression here, I am not writing it, this is here, this is here. You can see, yes or no, just that there is a plus sign in between, no change. Now a square minus b square in the top, a square minus b square in the top. So x power 4 is getting cancelled. Then you have a minus 2 into x cube. Then you have 3 minus c is 3 plus c into x square plus x term is what? B here minus 3 here, b minus 3 into x plus 2 here, minus of minus d is plus d here. ये कितना है? x power 4 plus blah 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 plus x power 4 plus 2x cube. यहाँ पे भी एक और टर्म लिख देता हूँ, ax cube plus same thing is here, so I am not repeating the whole story. As x tends to infinity, I have x power 4, x power 4 is a infinitely large number, उसके सामने x cube टिकेगा क्या? x cube से x power 4 कितना बड़ा है? Infinitely many times larger. And I am adding, not subtracting. Subtracting में क्या है? x power 4 cancel हो जाता है, तो x cube itself will become 0. But here I am adding in the denominator. So x power 4 is remaining intact. So next terms are all insignificant. There is no need to write them. They are pretty small, very small, infinitely many times smaller than x power 4. So happily you can ignore all those terms. ये कितना हो गया? x square. ये कितना हो गया? x square. So denominator what is it? 2x square. X is tending to infinity. Denominator is 2x square. Now can there be x cube term in the numerator? X cube numerator में है तो x cube by x square कितना हो जाएगा? x is tending to infinity. So answer depending on a minus 2 will be either plus infinity or minus infinity. So there should be no x cube term. If you want the answer to be finite, answer is given to be 4. Answer is given to be 4. It's a finite number. So x cube term should vanish. That means a should be equal to 2. Once x cube term is not there, now our focus will be on 3 plus c x square. ये लिखने की जरूरत है क्या? Not at all. As x square is there, x is insignificant, constant is insignificant. ऐसा है कि समुद्र में एक बाल्टी पानी जाके डाल दिया तो क्या होगा? कुछ नहीं होगा. So this x and constant are immaterial as long as x square is there. X square vanish हो गया तो बात अलग है, but as long as x square is there, these are immaterial. I will ignore them. So this ratio is given to be how much? 4. 3 plus c is 8. C is 5. C is 5. बस यहीं तक कहानी खत्म. B and D whatever they are, irrespective of that, answer will be 4. So B and D can be any real numbers. B and D can be any real numbers. A is how much? This term should vanish. A should be 2 and answer is given to be 4. So C 3 plus C should be 8 or C should be 5. These are the answers. Very simple question. This is again telescopic cancellation. I'll give you this for working at home. So just look at these terms. You will get some telescopic cancellation. In telescopic cancellation, what you should do, the general term, very important for your advanced, you will for sure get a question on your telescopic cancellation. The general term Tn, you should express it as difference of two consecutive terms of any series. You should express it as difference of two consecutive terms of any series. So tan x by 2 is there. See it as tan x minus x by 2, or just catch hold of the general term and focus on tan x by 2 power n, you see it as tan of x by 2 power n minus x by 2 power n plus 1. This difference will also be the same. Okay, यहाँ से शुरू करके you can expand it and get the result. Okay, so it is a question on telescopic cancellation. This question I said it will come to you. Only thing is the function inside. We have done this question previously also. This function inside will keep changing. Okay, so here whether I write integral part or not, it is not making any difference. क्यों? वो जो बचा हुआ difference कितना है? It is all fractional parts. Fractional parts add होके कितना हो जाएंगे? Maximum n. लेकिन कितना denominator है? n cube. So irrespective of what the fractional parts are, the answer is going to be 0. So this question will be as good as no integral part. 1 square plus 2 square into sin x power x by n cube. Okay, how much is this? Standard limit just now we remembered 1 by 3. Sin x power x, limit extending to 0. This is 0 power 0 form. 0 power 0 form. So 0 plus should be there. 0 plus should be there in the question. X power x ho, sin x power sin x ho, yeah, sin x power x ho, yeah, x power sin x ho. In all those cases, answer will come out to be 1. Okay? So answer will be 1 by 3. If you want to do it, you can apply logarithm. Let this limit be L. Limit extending to 0. Sin x power x is what we have to evaluate. It should always be 0 plus. Take log on both sides. Log L will be what? Log and limit can be interchanged because log is a continuous function in its domain. ये कितना हो जाएगा? x log sin x. x को नीचे लेके जाओ 1 by x. It is infinity by infinity form. Log 0 is infinitely large. Denominator is also infinitely large. So it is infinity by infinity form. Apply L'Hopital rule. This will be derivative of denominator is minus 1 by x square. Derivative of numerator is 1 by sin x into cos x, cot x. X cot x 1 हो जाएगा, एक और x बचेगा, तो this is 0, log L is 0, L will be 1. तो ये याद ही रख लो, x power x हो या sin x power x हो या sin x power sin x हो या x power sin x हो, all of these standard limits 0 power 0 form will all be 1, but only thing is x should tend to 0 plus. Okay, so this is how your questions on limits will be. It's a very easy chapter. Don't get bogged down by the how the question looks like. Questions look difficult, but they are not difficult in terms of doing them. Okay, so wish you all the best. See you soon with more videos on my classroom. All the very best.